Hello class, this is Mr. Wicklehouse. I'm trying to get focused in here so you guys can see my writing. There we go. And today I'm going to talk about the volume of solids, and this is just the first part of that. We only have a couple more videos left, and then you guys will be done with geometry, and you'll be able to move on and with life and move on to Algebra 2. So that's pretty exciting. So in any case, volumes of solids. I like to think of volume of solids in a couple of different ways. One is probably what you're more familiar with. The other, I don't know if you guys have ever thought about volume in this way. So the first thing and the most common, I think, when people talk about volume is filling up objects, whatever it may happen to be, with a bunch of little cubes. So each one of these little cubes, we completely fill the object up with all these little smaller cubes and fill it completely up until we have our whole shape. And then adding all those little cubes up, we get the volume of our figure. But if the figure that we're using isn't rectangular or a square or something simple that I can use these cubes. Sometimes when I try to fill up circular objects or other oddball shapes, then I'll have a lot of space left over or I'll be missing some space. So the other way I like to think about volume is by taking the figure, the three-dimensional shape, and just slicing it up into a whole bunch of little pieces, infinitely many pieces in fact. And then essentially all those pieces are stacked on top of one another, and that gives us the volume of our shape. So let's think about a cylinder here. And I take this cylinder and I slice it up into a whole bunch of little pieces. And I could keep slicing these pieces until I have really an infinite number of pieces, although that's not very realistic. We could think about that in our minds more abstractly. And then we'll get, after we stack all that up, then we'll get our shape. This is basically like taking a stack of pennies and stacking them all up. And then we can kind of move things around and get some different figures. And it's just really, I think, a more comprehensive way to think about it as opposed to filling things up with a cube where these oddball shapes that aren't very nice and tidy like the cube, we can think about our volume that way. There's several formulas that we can use to find volume. Ultimately, finding volume is essentially memorizing a bunch of formulas. And so I'm going to give you those formulas now. These formulas are derived from other measures of the shape, so from a side of a shape or from a radius of a circle. And when you move on beyond algebra, if you do move beyond algebra into calculus, you'll be able to see where these formulas can be derived from using a derivative or using integrals to find the area under the curves. And you'll be able to see more easily how area and volume are related. So let's just do a few examples and learn what the formulas for our shapes are now. So let me move this a little bit so I can see it a little better. There we go. So the volume of a prism. So we have multiple different types of prisms. These square prisms or rectangular prisms are probably the ones you're most used to seeing. And essentially that's just finding the area of the base and then multiplying that by the height. This one in particular is a square base, which we call a cube, which is basically, since all the sides are the same, I can just cube the side, and that will give me my area, or my volume rather, of my prism, which in this case is 1331. If this was rectangular, of course we wouldn't use the cube, we would just use the length times the width, and then multiply that by the height. The other types of prisms are these prisms that have more than 4 sides or less than 4 sides. And to calculate the areas of those is a little slightly more complicated. as you might remember from earlier in this unit, we have to use this piece called the apothem, which is from the center of our polygon to and perpendicular to one of the sides. So if the apothem is given to you, then you can just plug it into the formula. That is the number of sides times the length of the width times the apothem, and all of that divided by 2. As you have found out through homework and such, sometimes you have to calculate the apothem yourself or find the measure of a side using what we know about right triangles. In any case, the apothem in this one was given to us, so I do 6 times 7 times 8.7 divided by 2 and get 182.7. After I get the area of my base, it's simple after that, because I'm just doing the base area times the height, and 182.7 times 12 is 2,192.4. As for the pyramids, the pyramid is slightly different for the volume as opposed to what we've done before with surface area, because I'm not looking at the slant height of the pyramid. I'm actually looking at the height of the pyramid from the base to the top, so the actual height here, not the slant height, but the actual height from bottom to top. Okay. So remember, in surface area we did the slant height, and in this case that's not the case. So this will work for all pyramids, for finding the volume of all pyramids, so it's not quite as complicated as the surface area. In any case, so the formula for that, for the volume of the pyramid, is 1/3 times the base of the area times the height. So for this particular pyramid, we have the square pyramid. So the base, the area of the base is 4 times 4, which is 16. We're going to multiply that by the height, which is 6. So 1/3 times 16 times 6, that's going to give us 32. And that's basically all there is to finding the volume of the pyramid and the volume of prisms. In the next video, we'll go on to talk about a couple other volume formula. There's only a couple left. And when we're done with that, then we are done with this unit. And you guys will be ready for your final. I'll talk to you later.